We're talking about nth roots and radical exponents, and these next examples we're going to talk about how to rewrite radical into an exponential form. And so, and vice versa. Here we have, starting with a raised to the m over n power, and that is equal to the nth root of a to the m, or you can also write it as the nth root of a, and then whenever you solve that, then outside of the parentheses or outside of the radical, you can have the m on the exponent out there. This works the same way either direction. You can start with the radical form and work to the exponential form, or you can start with the exponential form and work to the radical form. Over here we have basically the same example. The only difference is we have a negative exponent. And in order to get rid of the negative exponent, we can move our value into the denominator, and then that makes our exponent positive. And then from there, the denominator of this is the same as it was up here. We can rewrite this. Whatever's in the denominator of the exponent goes on the radical, and then we can leave our exponent. We can write it in either way, either form. The only difference for this one is because a is in the denominator, a cannot be 0. So we have a couple examples, and we're just rewriting, in this case, rewrite the expression using a rational exponent notation, or write it as an exponent. So the 5 is the base. The base is going to stay the same. In this case, we do not have an exponent, so we're going to have an understood 1. So if it's not written there, that's an understood 1. So in the numerator, we will have the 1, and in the denominator of the exponent, we'll have the 3 that comes from the radical. Here, it tells us what the exponent is, but in this case, we have an understood value on the radical. So if it's not written on the radical, then we understand that there is a 2 there. So anytime it's not, I know a lot of times if it's not written, we understand it's 1, but in this case, it's assumed that it's a 2. And so when we rewrite this one, 3 goes in our base stays the same. Our 3 goes in the numerator, and then we have a 2 in the denominator. Same thing going here, except for this time both numbers are written down. Tell us exactly what it is. So our base stays the same. And then we have the 8 is in the numerator, and the 5 is in the denominator. And now we want to rewrite in the other direction. We want to go from exponential form into radical notation. So all we have to do is we keep the same base. Whatever was in the numerator stays as the exponent on the number. We don't have to write down the 1 if we don't want to. That can be understood, as we talked about earlier. And then we have to take the 5th root, because whatever's in the denominator goes on the radical. And we go and rewrite this middle one. Same thing, keep the parentheses in this case because we have to make sure everything gets distributed to both parts of the binomial. And the 3 is the radical, so 3 goes on the radical. Keep the parentheses, keep the base the same. And then we can either have the 2 written here, or we can have the 2 written outside the radical. Either one is fine. And then the last example there, keep the base the same. Whatever is in the denominator of the exponent goes on the radical, and then we can have the 7 written on the exponent on the y, or it can be written outside the radical. Either one is fine.